So today we'll be discussing a question from work power energy. Figure shows a loop track of radius r. A car without engine starts from the platform. Without engine starts from the platform as goes around the loop without falling. This car starts from here without engine. Without engine signifies u equals 0. U is initial velocity. Find the minimum value of h, this h, for a successful looping. Neglect friction. Okay, so this is the loop. This car slides down from here to here, gains the kinetic energy, and then moves forward and then goes around this. So we have to find the minimum value of this h for which this looping can be done. This looping will be done if there is a certain minimum velocity here for which the loop can be completed. So let's apply. So let's this mark it as A, this B, C and D. So from A to B, see here let's suppose it has a velocity v1. So half m v1 square equals mg times the total height from here to here is the vertical height, this one, which is this height is 2r, so this is 2r and a small h, so mg times 2r plus h. Okay, so this moves from velocity with the velocity v1 and there is no friction, so here also the velocity is v1. So here also the velocity of the car is v1. Let's suppose the car goes around here and here it has a velocity v. So from C to D, half m v1 square equals half mv square, work energy theorem, plus mg times 2r, because the car has a velocity v here and a potential energy 2r. R is the radius, so r here and r here. So 1 and 2. We don't know the value of v, so equating 1 and 2 we get mg times 2r plus h equals half mv square plus mg times 2r. So if we open this, and so this terms will get cancelled and we will be left out with mg times h equals half mv square. That goes h equals v square by 2g. Okay, so we have to find this v. Now let's consider the loop again. It's kind of this. It has a velocity v here. So for minimum criteria, let's just suppose that it has a centripetal force mv square by r, and from the figure, from the free body diagram, we should know that the weight, that is the mg minus mg plus normal reaction, should be causing the centripetal acceleration mv square by r. So for minimum n equals to 0. N is the normal reaction. See, here's the thing, it's at the top of the loop. Mg is acting, normal reaction is acting, and this mg plus n is causing the mv square by r, that is the centripetal acceleration. So for minimum centripetal acceleration, because we have to find the minimum conditions, we consider n equals to 0. So mv square by r comes out to be mg. That means v square equals r times g. We put the value of v square equals here. So v square is r times g by 2g, g cancel, r by 2, which is the h minimum. It is r by 2. So for minimum velocity, just completing the circle, we need h is equals to minimum r by 2. And here's the question. Thank you guys.